Mission overview of Aditya L1. Launch date, September 2nd, 2023. Launch vehicle, PSLV-C-57, Polar Satellite Launch Vehicle. Orbit. The satellite is placed in a halo orbit around the Lagrange point 1, L1, approximately 1.5 million kilometers from Earth, where the gravitational forces between the Earth and the Sun balance. This location provides an uninterrupted view of the Sun.
PSM ignition ആരംഭിക്കാം.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal. P1 tracking. Tracking.
Magnificent lift-off of PSLV C-57 with Aditya L1 on board.
Satellite separation. Journey of Aditya L1 to L1 point. The spacecraft was initially placed in low Earth orbit, LEO, approximately 235 kilometers by 19,500 kilometers. These maneuvers gradually increased the apogee, farthest point from Earth, until the spacecraft had enough energy to escape Earth's gravitational influence. Once the spacecraft reached a high enough orbit, it was injected into a trans-Lagrangian trajectory. Aditya L1 traveled about 1.5 million kilometers over several weeks, adjusting its trajectory using small course correction burns. Upon reaching L1, Aditya L1 executed a final maneuver to enter a halo orbit around the L1 point. This orbit ensures a continuous view of the Sun without any obstruction from Earth or the Moon. Why L1? At Lagrange point 1, the gravitational forces of the Earth and the Sun balance each other, allowing the spacecraft to remain in a stable orbit with minimal fuel usage. It provides an uninterrupted view of the Sun, essential for studying solar activity like solar flares, coronal mass ejections, CMEs, and solar wind dynamics. Payloads, instruments on board. Aditya L1 carries 7 payloads: Visible Emission Line Coronagraph, VELC, Solar Ultraviolet Imaging Telescope, SUIT, Solar Low Energy X-ray Spectrometer, so LEXS, High Energy L1 Orbiting X-ray Spectro, METER, HEL10S, Aditya Solar Wind Particle Experiment, ASPEX, Plasma Analyzer Package for Aditya, PAPA, Magnetometer. VLC studies the solar corona. SPEX analyzes solar wind particles. SUIT captures images of the sun's photosphere and chromosphere. HEL10S studies high-energy X-rays. So LEXS monitors X-ray flares. PAPA measures solar wind ions and electrons. Magnetometer measures magnetic field variations at L1. Aditya L1 data transmission collects solar data, captures images, X-rays, and solar wind details, processes and stores, partially processes data on board, transmits to Earth, sends via X-band to Isro's Indian Deep Space Network, IDSN. Ground processing, data is analyzed for research. Scientific use helps study solar activity and space weather. Mission duration planned duration 5 years. Purpose: long-term study of solar activity, space weather, and solar wind dynamics from Lagrange Point 1, L1. Mission objectives: study solar corona, analyze coronal heating, flares, and CMEs, measure solar wind, observe solar wind properties and space weather impact, monitor magnetic fields, track sun's magnetic activity in interplanetary space, detect solar radiation, capture X-ray and UV emissions, forecast space, weather, aid in predicting solar storms affecting Earth. Unveiling the secrets of the sun, Aditya L1 marks India's leap into solar exploration, lighting the path for future discoveries.